Welcome back to DGE Tutorials. Today we are discussing basic trigonometric identities. These are equations involving trigonometric functions, sine, cosine, tangent, cosecant, secant, and cotangent, that are always true, regardless of the variables used. They are used to simplify expressions or solve trigonometric equations by rewriting them in different but equivalent forms. Here's a more detailed breakdown. Trigonometric functions are functions that relate the angles of a right triangle to the ratios of its sides, opposite, adjacent, and hypotenuse. An identity is an equation that is always true for all values of the variables involved within the domain of the function. Basic identities are fundamental relationships between the trigonometric functions that can be derived from their definitions and properties. Uses of identities include simplifying expressions, where identities can be used to rewrite complex trigonometric expressions into simpler ones. Solving equations is another use, where identities can help transform trigonometric equations into forms that are easier to solve. Proving other identities is also possible. More complex trigonometric identities can be derived by applying the basic identities. Examples of basic identities include reciprocal identities like CSC theta equals 1 over sin theta, sec theta equals 1 over cos theta, and cot theta equals 1 over tan theta. Quotient identities like tan theta equals sin theta over cos theta, and Pythagorean identities like sin squared theta plus cos squared theta equals 1 plus tan squared theta equals sec squared theta, and 1 plus cot squared theta equals CSC squared theta. For example, the Pythagorean identity sin squared theta plus cos squared theta equals 1 can be used to rewrite an expression like 1 minus cos squared theta as sin squared theta. Here's an example demonstrating substitution and combining trigonometric identities. Simplify the expression sine of x times cosine of x divided by 1 plus cosine of x. Solution. First, substitution. We'll use the identity sine squared of x plus cosine squared of x equals 1. We can rearrange this to sine squared of x equals 1 minus cosine squared of x. We also need to consider the quotient identity tangent of x equals sine of x divided by cosine of x. Next, combining and simplifying, our expression is sine of x times cosine of x divided by 1 plus cosine of x. We can rewrite sine of x times cosine of x as sine of x divided by cosine of x times cosine squared of x. Substitute tangent of x for sine of x divided by cosine of x, so we have tangent of x times cosine squared of x. Now we want to get rid of the cosine of x in the denominator. We'll use the Pythagorean identity. We know 1 plus cosine of x can be written as 1 plus cosine of x divided by 1 plus cosine of x times cosine squared of x. Now we can multiply by the conjugate of the denominator to simplify tangent of x times cosine squared of x times 1 minus cosine of x divided by 1 plus cosine of x times 1 minus cosine of x. This simplifies to tangent of x times cosine squared of x times 1 minus cosine of x, all over 1 minus cosine squared of x. Using the Pythagorean identity again, where sine squared of x equals 1 minus cosine squared of x, we get tangent of x times cosine squared of x times 1 minus cosine of x over sine squared of x. Finally, we know that tangent of x equals sine of x over cosine of x. So we have sine of x over cosine of x times cosine squared of x times 1 minus cosine of x over sine squared of x. Simplifying further, we get sine of x times cosine of x times 1 minus cosine of x over sine squared of x. And finally we arrive at cosine of x times 1 minus cosine of x over sine of x. The final simplified expression is cosine of x times 1 minus cosine of x over sine of x. Here's an example demonstrating factoring and combining trigonometric identities. Alright, so here's the problem. We're asked to simplify the following expression, sine squared x minus 2 sine x cosine x plus cosine squared x. Let's break it down step by step. Step 1. Recognize the structure. This expression looks like a perfect square trinomial sine squared x minus 2 sine x cosine x plus cosine squared x equals the quantity sine x minus cosine x squared. So we can factor it as the quantity sine x minus cosine x squared. Step 2. Use an identity or optional expansion. If we expand it back to verify or use identities, the quantity sine x minus cosine x squared equals sine squared x minus 2 sine x cosine x plus cosine squared x. We also know the Pythagorean identity, sine squared x plus cosine squared x equals 1. So if you go back to the original expression, sine squared x minus 2 sine x cosine x plus cosine squared x equals the quantity sine squared x plus cosine squared x minus 2 sine x cosine x, which equals 1 minus 2 sine x cosine x. Final answers, factored form the quantity sine x minus cosine x squared. Simplified using identity, 1 minus 2 sine x cosine x. Hope you find this useful. Please don't forget to share and subscribe. See you next time.